Hi, I'm Glenn Aguilar from Leiden University. It is a pleasure for me to present the research about the circularity gap of nations. In the following presentation, I will explain the motivation of this research, describe what is the circularity gap, and show the highlights of the paper. Our current economy can be described as linear. We extract materials from nature, use them, and dispose them back into the environment. It is clear that this system is not sustainable in the long term. That is why the circular economy has emerged as a paradigm in which materials are retained into the economy. From a policy perspective, it is important to monitor which policy measures are more effective for resource efficiency. In this sense, previous studies have proposed metrics, for example, the measurement of recycling rates. Although this is a relevant metric, it doesn't show how much unrecovered waste can be reintroduced into the economy, which is also the amount of materials that can potentially use for recovery or recycling. This is what we call the circularity gap. To calculate the circularity gap, we need to know three elements. First, ordinary waste, as the waste generated in a single year. For example, single-use plastics. Second, stock depletion, as the waste that comes from in-use stocks. These are durable products, such as buildings, cars, that are discarded in a specific year. Finally, waste recovery, as the amount of waste captured by recycling industries. The circularity gap of a country in a specific year is the ordinary waste plus stock depletion minus waste recovery, as shown in the equation. We calculate the circularity gap of 48 countries and regions worldwide by using the multi-regional input-output tables from ExioBase. Looking at the global material inflows and outflows, we can see that the global circularity gap represented less than 10% of the global material extraction. This is because 50% of materials are extracted for food and energy purposes, which becomes dissipative emissions, and 40% of material extraction goes into stock additions, or durable products such as building, infrastructure, and transport equipment. This limits the amount of material available for recovery or recycling at the present, but also shows that the stock additions are quite important for a circularity transition, where the in-use stocks can be seen as a material reservoir for the future. Moving on to the regional perspective, we identify which policy interventions can be implemented to reduce the circularity gap depending on each region. For example, in high-income regions like the European Union, the circularity gap showed a high level of waste recovery, but also a high level of stock depletion. Then, product lifetime extension can be implemented as a policy intervention to delay stock depletion and reduce the circularity gap. In middle and lower income economies, such as the Asian Pacific and African countries, the circularity gap was characterized by a high degree of waste generation with low recovery. Then, residual waste management and resource efficiency are crucial policy interventions for these economies. I hope that our findings can provide relevant information to support decision makers on implementing circular economy policies in the future. I would like to thank the PRISMA Work Committee and the organizers of the Dresden Nexus Conference for the opportunity to present this research. And thank you all for listening. Please feel free to contact me if you have any further questions. Thank you.